day 14. Let's do this. Okay. Okay. Wait, what? Okay, up. It's up. It's okay. Okay. So what's the safety factor? Oh, in each of the quadrants. Okay. Seems pretty simple. This seems like a part one that where you set it up in part one and then you actually do the calculation in part two. So position velocity is equal to y split based off space, and then position px py is equal to position split equals sign. The second one where we split by comma, and then we map it to a number. Let's spell it right, that'd be lovely. That's pypx, and we can do the same for that. And we need to return position x, px, y, py, and then velocity, same thing, so bx and by. And we need to change this to velocity, and then b. Alright, I think that's all we need for robots. Just gonna confirm that. Ooh, perfect. I knew there would be a problem. Let me actually just, I'm gonna steal the bots here. Oh, so they can overlap. I think that's what it's saying. Yeah, they can overlap, which is, I mean, that's fine. So what is, okay, so that's right. Weird. And then I guess the quadrant, what would the quadrant be? I guess, so we have the min, so we obviously have the min and max height. So how many, after 100 seconds, so for equals 0, I is less than robots dot length I plus. So simulate 100, so robots of I dot position dot x is equal to position, or not prompt, is equal to this plus the velocity times 100 all. But what's the grid? The robot's outside the actual bathroom. Oh, okay, it is 100, so that's our width and height. I was wondering what was happening. Width is equal to... It's very weird. And then this is my width, and we actually need to put velocity. And then y is the same thing. Very simple. Times 100 y height. And then now we just need to count for that y equals 0, y is less than height, y plus. x, let quadrants equal that, or I don't even need this can be a const, and then we reduce it by multiplying whole times num1. This could be a number array. In fact, so quadrant is equal to, so I guess it doesn't really matter, so we could just do x divided by, or sorry, if x, so I'm assuming this is like 0, 1, 2, 3, 4, 5. If x is equal to width minus 1 divided by 2, which, or y is equal. So if it's in that in between, then we don't count it anywhere. Math.floor. This is going to be height y. I don't even know why I'm doing that. I could just go through and do it when the robots. Because it seems weird, yeah. It does seem weird. So we still simulate it, right? But we don't have to. So if it's in the in-between, then we say, okay, what is that? And this will be times 2. And let me just confirm this to be right. Oh, that don't work. I thought it would either be, actually, let me do that. That makes sense. We're just divided by width and divided by height. And well, this is obviously the wrong height. So what was the example? 11 by 7. Okay, and then this is negative. Why is it negative? Oh, because up is negative for some reason. Yeah, that is weird, because this is... Oh, wait, I think I know the problem is because this could be negative. I'm assuming all of them could be negative. Yeah. One thing I could do is I can also multiply by the width times 100 and the height times 100, and then that should still wrap correctly. Not match. Oops. Okay, now that's all 0. Because that's the thing, is if we multiply by width and height, it shouldn't change the position. There should be one at 0, 2, which there is. And there's one at 6, 6, 0, 1, 2, 3, 4, 5, 6. And then 6, yeah. And then there should be 2 at, is it 7? Is this 6, 0? 6, 0, 6. Okay, so yeah, that's right. And then width minus 1 is 5. So if it's equal, if x is equal to 5, or y is equal to 3, then we don't count it. Does it belong to any quadrant? And then, yeah, so we continue here. And then we check the position. In fact, I'm just going to do it like this, just to make stuff consistent. Okay, so then 1, 2, 3, 1, 2, 3, 1, 1. Ooh, so it counted 4 robots. So it counted 2, 3, 3, and 1, 1. So quadrant 0 means this one, which apparently doesn't. Well, it shouldn't matter as long as oh wait. Pfft. No wonder why I was so confused. Okay. Which one? Oh, these are definitely different quadrants. One thing is if they're at if they're at 7, say like, or they're at 0, 0, 1, 2, 3, 4, 5, 6, or well, it's 1, 6, then this will be 2, which we don't want, and so we need this to be ceiling. Okay, so 1, 3, 1, 1. Okay, so it's still the same issue where we have 8 when there should be 9. So somewhere along the way, lots of I position. So this is just going to confirm that what's being left out. So 9, 0, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Perfect. And then there should be 2 6 zeros, which there are. And then there should be a 0, 2, which there is. And then 0, 1, 2. There should be 2, 4, 0, 1, 2, 3, 4, 5. 2 4 5s? Ooh, which do not exist. I'm going to confirm. Ha! I always like getting my variables messed up. Okay, 2 2 2 2 1 1 1 0 3. Perfect, which makes sense. And so then what we can do is we could just say quadrants of quadrant plus plus, and then we can reduce it, which should give us 12 here. And then oh, I know what the issue is. I forgot to trim. So then we'll get rid of this comment. Wow, if this is my answer, yeah, it seemed too perfect. It seemed too perfect. Oh my gosh, I'm an idiot. I forgot to update the 101. I forgot to update the width and height of the quadrant. So we have this, which I'm going to have to wait a little bit. But let me see if I need to. I don't think I really need to update anything. So maybe part 2. I can't imagine it being I feel like the quadrants are just checking. What it could be is that we have to implement a quad box for collision detection, because that is, oh man, 2 seconds, really? Okay, there we go. What is the fewest number of seconds that must left? Oh my gosh, they have a hard-coded Easter egg. Very rarely most of the robots should arrange themselves into a picture of a Christmas tree. What? I legit have no idea how to do that. So that means I'm going to have to change how I do it. So I don't need quadrants anymore. I'm going to do it as a step, and I'm just going to hard code 1,000 steps. What? So then we don't need times 1,000 anymore. We don't care about this. And then, yeah, okay, that's all we need. I think what I'm going to do now is, oh boy, okay, this is different. Robots of I dot map not robots of I, robot dot map robot position dot x. Why is this? Oh, do I have to yeah. I have to spread it, and then we do that. So we have max x, we have min y, we have max y. So this is max, this is max, and then this is y. And I'll just do, like, I guess I'll do a 2D. I have no idea how to detect a Christmas tree besides just printing them out. In fact, what I'm going to do is I'm going to just write it to a file. So that content is equal to that. So then content plus equals step plus a new line. And then y is less than y is plus xx width. And then we need a row. Let row equal that. If robots of I dot find, not robots of I, robot dot find, robot where row, robot dot position dot x is equal to x, and robot dot position dot y is equal to y is not equal to undefined. Row plus equals hashtag else row plus equals a space, and content plus equals row, and then a row new line, and then now will be separated. And so then Dino dot write text file sync test.text with content, and I'm just going to return 0 for now. I have no idea how to detect it, so I'm just going to print it out. I don't know why, I just realized I don't need any of this. Let me just do 100 steps. Insert on. Okay, running, so it did it, and then I should have a test file here. Ooh. This just looks like random noise. The closest one I see to them congealing a little bit is 18? Somewhat? Not really, though. Okay, well. So now I'm going to go up to 200. We should arrange them into a picture of a Christmas tree. See, that's the thing, is I just don't know what would classify as a picture of a Christmas tree. No. Very close, though, but not really. Yeah, all noise. One thing I could do is I could have this to like start it off, so I'll do that. So I'll have let start step is equal to 200 and step is equal to 300. We'll have this go for this many. also going to have to do that. Oop. Then copy it. And then I can remove any of this bit. Don't need that bit. And then, so this allows us to do that, and then this is end step minus start step. So then this allows us to check between 200 and 300. It's another thing. Oh wait. Well, it shouldn't. Step plus start step. I don't know. Hold on. I could just do start step is less than or equal to end step, and then step. I don't know why I did that. I've already seen 200 to 300, I think. I also, am I just, I'm not, is this a loop? Let me check. So, wait a minute. Okay, I see a pattern emerging at 24 and 76. So if this should be 20, something. So this is 30. $30, $47. Okay, so something is definitely happening at these steps. So it looks like every 101 steps, and then between, what was it, 77, so there's 430 and 77, so that's 26. So every 101 steps, step size is equal to 101, and then we'll just do steps of interest. Well, where does it start? Let me check something actually before I go too crazy. Start step, and then we'll go back to 0 and 100. Where does it start? Okay, so here's 18. 18, and if my theory is correct, if it's 26, then it should be 44. Where this? Or, oh, 73. 18 and 73. Okay. Wait. But this goes up, right? So hold on. So if my assumptions are correct, it should be 19 or 275 and 224. Oh wait, I skipped. I skipped 100 to 200. I was like, I skipped a lot. What I think it is if I'm not mistaken, so if this is 18, then this is 121. Oh, so this is a step size of 3. And then this should be a step size of 1. Where's the number that goes along with this? Oh, there it was. 174. Ooh. So when does, I need to pull up Desmos again. Desmos? When does 3x plus 18 equal 70. It was 73. I think it was 73. X plus 73. Where does that equal? Hey. Okay. This equals it at 27.5. So something tells me I need to look at 27. I'm going to do 26 to 2008. Just do 200 steps increment. Go back to here. Nothing of interest so far. Very close though. And then oh, okay. Goodness oh me. I think we are starting to get close to it. So let me add 50. Or let me add 20 more. That's not one. I have no idea how to do this. I mean, obviously I can tell when they're collided, obviously. 2800, 20. Okay, that's just nothing. X is I'm just going to say X is equal to 28. And then feels like that's not right. How would I let me check what the leaderboard's saying. Okay, so there are plenty of people who got it. It's just crazy. The only thing I can think of, right, is when they're compact. That means we're more than likely, looking at this, we're more than likely to see I'm going to say a 5 by 5 square. So let me just see. Let me just test something real quick. So let's not generate. Let's not generate anything, and let's just go from here to 3000. How fast does this run? Okay, that runs pretty fast. And so I don't need this. I think what I'll do is I'll move it, and then I'll check for a robot. Let j equal -2. J is less than or equal to 2. J plus plus. J, K, 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 and then I'll do the same thing I'd had here, where it'd be X plus K, and then Y plus J, and I'm going to do that, and I think I also need robots dot position. So this checks let neighbors is equal to 0. Neighbors, if neighbors is equal to 25, console.log step. So if there's a 5 by 5 grid, I shall try that. So obviously it's doing more because now it's searching a 5 by 5. Oop, I just realized that will break because it's going to be undefined. And I'm also going to console.log Let me just see how fast this is running. Okay, it's running relatively fast. Another thing I can do is I can make this faster because most of the time neighbors is equal to true. If we find one that's not a neighbor, all neighbors is equal to false. And then if all neighbors, so this shouldn't be much faster because essentially it will it should be able to skip all the positions. And another thing, but it's the same thing. Caching shouldn't actually make it too hard. So const positions is equal to new set of robots.map robot to row, and it's just going to be a string of robot.position x, robot.position.y. And then instead of doing this, if robots doesn't have, I can say, doesn't have, now string I feel like string operations though would be slower or faster than array operations, but that's just if I am so wait. So then we move all the robots, and then we get all the positions, and then we check each robot again. Each if positions.has. Robot I.position.x plus k. I have no idea how I would find this. Not j, this is supposed to be y. If it's doesn't have it, then all neighbors is equal to false. If it's not, if all the neighbors are true still, then we cancel all one step, and then we check. So yeah, that is much faster. So now that we know that it's much faster, I'll do this to see if there's actually anything found. So nothing found at 3,000. If step mod 1,000 is equal to 0, we console.log it. Another thing is I also could be just looking at the wrong thing, and that it's not a filled in tree, which I'm kind of scared that's the case now that I'm thinking about it. I don't want private leaderboard. I'm going to look at the mega thread to see if it's a filled in tree or not. In fact, I think of visualization part 14. Okay, no. So far, nothing. Oh. Well, that kind of gave it away. Darn. Darn. Well, I was almost there. So I don't need to apparently do all that. So was there a thing in the thing that if they're the same type, they should have a hard-coded Easter egg? Very rarely, most of the traits are breeds. So it doesn't say anything about that though. So for each step, we check that, and then positions is that if positions.size is equal to robots.length console.log the step. which kind of sucks. I'm going to go to 10,000, which I don't really need this anymore, but I still have it. Oh, so it okay, found it at that. It's not right. I'm assuming it's a one off by one error. Let me try something. Oh wait, it's. I'm going to do 7,000 because apparently that's where we found that. Okay, and then we go to test. Yes, this definitely doesn't have a Christmas tree inside of it. Very rarely the robot should have tree. Well then, okay, I'm going to pull up that mega thread again because now I am confused. Search for the subprinted grid, which was nearest. Okay, well that's what I did. What? Okay, that's weird. I think I'll do that, but I'll just keep going. So found 2, right? Oh my goodness. All right. What? Oh my gosh. Because it's that +1, which is why everyone was talking about a 1. Okay, well that looks pretty cool. But so my assumption was right that a 5x5 area does exist. So because it's just really slow. But I'm going to try to submit that because that is what, I think is... How fast? Okay, 21 seconds. That is what I think. I'm going to take this also. Just going to... So this is the grid correct. It does suck because we didn't know what the tree looked like. But my initial assumption was correct that there would be at least one group of 5x5. And then I'm assuming all this random noise is like where the input variation is. Okay. So I should be able to submit it now, which is this one times 3. Okay, or +1. Boom. I can't imagine that one being a quite popular one. So now, yeah, still, it took me 40 minutes because I just didn't know what the notation was for it having its own thing. So I'm going to remove I'm not going to remove the unique positions, but I'm going to remove that check. It's not the check I was going for initially. So now we need our 2x2 loop again. -2 j is less than or equal to 2. And then it's going to be k. And then what we're going to check for is if let has has group, and that's going to be true because we're optimistic and we're thinking it has a group. And then if positions dot, if it doesn't have a robot at that specific position, plus k y plus j, then it does not have a group. It is false. So then we could just say if it has a group, return step plus 1. So yeah, I think, and then what I'm actually going to do is I'm going to say if step, so at that point, this if step mod is equal to 0, console.log step. And so this should allow me to see how fast this runs. So it should take, I'm going to say tree. What? Okay, weird. Because it definitely has a 5x5 at some point. In fact, and then if has group break. Oh goodness. So that should make it faster because a lot of the time the grids don't have. Okay, there we go. For some reason that one worked. Oh wait. If it doesn't have. Okay, well that worked for some reason, but that one didn't. Why? Why? Why did that work? Goodness on me, why did that work? So it goes through and it checks a 5x5 square around the robot. And if it doesn't have it, that means it's not a group, which means that it shouldn't continue the search. Actually, this one shouldn't, because a different robot might have it, but it shouldn't continue at least that current's 5x5 search. Okay, so it still does it. Because that's the thing, is like, this technically just searches one row, which, I mean, to be fair, yeah. But like, why? Why? Why does that work? Okay, robots of I. J. So it goes -2 to 2 with 0 involved. I mean, it doesn't matter because position.x plus k and then position.y. And if it doesn't have it, then it's not a group because it says that it means that it's one of these empty spaces, which makes sense. And the only, so like, see, because I have no idea why that would be the case. Why? So let has group is equal to true, and then it does a 5x5 search centered around the robots, and if the position doesn't include that, then it doesn't have a group. Which I don't know why. I don't know why me doing that returns the correct answer, or it doesn't return the correct answer. Oh wait, because I know why, because I did this in the wrong loop. And so this should still speed things up. It's just I did this in the wrong loop. Okay, which that still speeds things up. So, okay, now it's incredibly broken. Okay, so that's correct. So then now I should be able to break out of this if has group break. And that should speed things up. Okay, it does. Perfect. So then we don't need this anymore. Okay. I'm pretty happy with this solution because it's the solution I came up with. I wasn't going to take the mega thread solution. But all right, that's it.